extend this line, extend this line, extend this line of action of 80 Newton. This one connect 80 Newton. This one we will have one force here. We will get one force here. All the forces, this force from link number 3 will always act parallel to this one. So we will have one force parallel to link number 3, because the link will be subjecting either in this direction or in this direction force on link number 4. So just draw a force parallel to a line parallel to link number 3 by drawing line parallel to link number 3. We will have this one. Now all the forces should pass through. Now we have line of action of force which is coming from 3, this direction. Okay. Now we have line of action. Now connect this one to point D. This is point D. This is point C. So we have the single intersection point of all the forces. This one. We have done this one. Okay, because the member is in equilibrium, we have drawn a line parallel to this one here. So this will intersect like that. Okay. Now we will calculate the magnitude of this force and magnitude of this force by drawing the triangle law of forces. Now draw 80 Newton here, 80 Newton here, 80 Newton by taking suitable dimensions. Now 80 Newton here, 80 Newton will be here. 80 from 80 Newton draw this force will be F force by member 3 on member 4. Now we have direction and connect this one to this one. We will have F force by the member 1 on the member 4. So we can get this triangle by taking the condition that the mechanism is in static equilibrium. So we will have this force triangle. We have this one 80 Newton. By taking suitable configuration, we can calculate the value of F34 and F14. F34 and F14. Now we have this force F34. F34 means on the member 4 we are having one force is acting in this direction, magnitude and direction F34, and one force is acting here. One F, this force F. At this point we are having F14. Now we have F34. We have magnitude and direction. The magnitude of F34 according to the question is coming 47.8 Newton. F34 is coming 47.8 Newton. 47.8 Newton. Okay. So if on the member 4 by the member 3 force is acting here, so by taking the equilibrium condition by this member, by member 4 on member 3, the force will come like that, the compressible force. This will also equal to F43, which is 47.8 Newton. Okay, the member 3 is in equilibrium under the action of two forces. Then the second force will be equal and opposite in the same line of action and the same magnitude. This force is nothing but F force by the member 1 by the member 2 on the member 3 with having the same magnitude 47.8 Newton. Okay. Now this force, now we have member 1 is here. If this force is acting this direction, then on the member 1 we will have one opposite force of magnitude F32 by the member 3 on the member 2 in equal magnitude 47.8 Newton is acting here. Now the member 1 is in equilibrium under the action of two forces and a moment. Moment is externally applied, but we have one another force according to the condition. If a member is in equilibrium under the action of two forces and a torque, then the force should be equal. And this force is F, force by the member 1 on the member 2 with an equal magnitude, this one. Now this force F32 and F12 will create a moment in anti-clockwise direction. For the equilibrium, we have to apply a torque in opposite to this moment, means torque in clockwise direction we have to apply for the equilibrium of member 1. So we will apply a torque equal to opposite to the moment. Let's say this distance is h. Moment will be F12 multiplied by h or F32 multiplied by h or 47.8 multiplied by h. That h value we will calculate from the configuration diagram. Okay, from the configuration diagram, this value we will calculate from the configuration diagram. Draw a parallel line here and calculate the exact dimension of h from the configuration diagram. When we will draw all the forces, we can easily calculate the value of h. In this question, the value of h is coming 393 mm. So we are having this 47.8 multiplied by 393. We are having 480 Newton mm. This value is coming, h is coming 393 mm. So we are having this one, we can convert this one 87.8 Newton meter by converting mm into meter. So this amount of force, this amount of torque is producing by these two forces. Now we have to apply externally an equal and opposite torque to this movement. Then the member 1 will be in equilibrium. Okay guys, so the moment produced by these two forces is anti-clockwise. So we have to apply a clockwise torque of 18.78 Newton meter for the equilibrium of the mechanism. Okay, the question was determine the input torque. So the value of input torque is 80.78 Newton mm in clockwise direction for the static equilibrium of the mechanism. Okay, so the question was we have to calculate the externally applied torque T for the static equilibrium of the mechanism. How we have started the question? First we have drawn the configuration diagram by taking suitable conversions of the unit according to your base. Okay, so first we have drawn the configuration diagram. We have drawn this force one. Okay, we will start the question from here. Okay, we will start the question from here because the 80 Newton force is given. Okay, we have member 4, 80 Newton force. We know that the force exerted by member 3 on member 4 will be in this direction, either extension or compression, either here or here. So we have the direction. We have the direction. We don't have the magnitude. For direction, we have drawn this one. This point we have achieved this intersection point. Now intersection point we have connected to point D. Why we have connected to D? Because the member is in static equilibrium under the action of three forces F34, F14 and 80 Newton. Okay. The condition is all the forces should meet a single point and they will form a closed triangle. Okay. So this one we have the dimension. Okay, now we have the directions of forces by meeting at this point. Now we are drawing the force triangle 80 Newton. From tip of this one we have drawn the F34. This one here, then here we have connected F14. From this point to this point we have the force triangle. Okay, this one again we have to take care of the dimensions. 80 Newton is this one length, then this length will give the magnitude of this one, this length will give the magnitude of it. Now we have F34. On link 4, F34 is acting in this direction. So on link 3, F34 will act in this direction, compression. Why this is compression? Because the member is in equilibrium. Okay. So this one, if this force is coming this one, the link 2 is in equilibrium under the action of two forces, then the line of action of force should be same and will act in the opposite direction. If this is coming this one, then this will come like this one. Okay, so we will have F23. This force is by the member 2 on the member 3. F23, 47.8. The same magnitude is coming. Now on the member 1, link will provide one force in this direction F32. F32 is coming this one. Now this member 1 is in equilibrium under the action of two forces and a torque. The torque which we have to calculate. The two forces. The force should be, if a member is in equilibrium under the action of two force and a torque, then the force should be act parallelly and equal in magnitude. So this F32 and F12 is coming from here. Force by the member 1 on the member 2. F12 is coming here. 47.8, 47.8. This H distance is the perpendicular distance between two forces, which we will calculate from the configuration diagram. This distance is coming 393 mm. Force was 47.8. So the moment created by these two forces is equal to 18.78 Newton meter. So the moment created by these two forces is in anti-clockwise direction. For the equilibrium, we have to apply a clockwise torque. Of the same magnitude. Okay, so we have applied a torque of 18.78 Newton meter for the equilibrium of the mechanism, static equilibrium of the mechanism. Okay, the question is very simple, but the question requires a lot of practice. So you have to practice this question. In the next lecture, we will discuss more numerical on the equilibrium of the four bar mechanism and slider current mechanism. Okay, so practice on this required a lot of practice. Practice this question. We will meet in the next lecture. Thank you.